Good evening, everyone. So welcome to the day number 3 of our image processing workshop. So last time we discussed about color segmentation, as you can remember. So what we are going to do today is start from there and continue our discussion on color segmentation, and also then we are going to do example, a project based on color segmentation, and that would be the plant height detection, which I showed you last time. I showed you the code and I showed you the output as well, right? Okay, so in order to do that, I hope you can remember what is this HSV color format. I told you that in color segmentation, we are not going to use the RGB color format. Instead of the RGB color format, we are using the HSV. Since HSV color format is like using HSV, it's quite easy for us to and the computer to detect, do color segmentation, right? So in order to detect objects using color for computers, it's easy to use HSV than using, instead of using RGB, right? So that's why we learned about HSV color space, right? So I know I assume that you remember what mean by HSV, right? So H is the component which simply represent the pure color, right? So H component is about pure color, and saturation is about the color amount of color used, and the value is the brightness of that color, right? Got it? So in OpenCV, I told you that this at the last part of last session, right? So you know that H component lies between 0 to 180 in OpenCV, right? I'm talking about the values in OpenCV, right? And also S lies between 0 to 255. V also has the same range, 0 to 255, right? But generally what say, right? 0, this is 0 to 360 in general, and this is 0 to 100%, and it's taken as a percentage, right? This also is taken as a percentage in the practical scenarios, but in OpenCV, this is the range, right? So this is the range considered. Got it? Okay, now we want to see how we can perform color segmentation, right? How we can perform color segmentation. So I'm directly going on to a code, right? So now you need to understand what color segmentation is about. Like it's basically detecting a kind of segmenting an object or an area in an image, right? So segmenting an area or an object in an image based on the color. That's what simply color segmentation is about, right? So I'm going to take an example in the samples folder. There's a image called color3.jpg. So I'm going to open it and I will show that image to you. Then you can see the image that we are going to we are dealing with, right? So this is what you have, right? So this is the color3.jpg image, right? The color3.jpg image. So what we are going to do is, now let's say that right? So let's say that we want to detect there are lids, you can see, right? So there are lids, right, of some containers. So let's assume that we want to detect a particular color, right? Let's say that we want to detect a particular color. For example, let's say that we want to detect this blue color, right? We want to detect this blue color, let's say, right? Now, just for example, right? So let's say, okay, we want to detect this blue lid. That's what we want, right? So how we can do that, right? How we can do that? Simply what we can do is, we want to first, now we are going to perform color segmentation, as you know already. We are going to perform color segmentation. So in order to do that, what you have to do is you have to first convert this into the HSV color format, right? So you know the function that the method that we are going to use for that color conversion, convert color, and we are going to pass the original image. Then we need to provide the color conversion flag, right? So we are going to use BGR to HSV. Then we can take the resultant image into a particular object. So I'm going to name the object as HSV, right? So let me show you the HSV image, right? So this is actually, this cannot be understood by us, right? Since it gives you something like this, right? But anyway, what we are going to do now, we are going to perform color segmentation. In order to perform color segmentation, you have to have two colors, right? And these two colors are like, we will discuss how we are going to obtain these two colors. Now, these two colors are the colors that we want to detect blue color, right? So these two colors, we are going to use these two colors to detect the blue color lead, right? So don't worry about that. I mean, how you actually how I'm like how these values are there, right? So based on what you decide these values, right? Anyway, don't worry about that. I will explain it in a minute, right? So anyway, let's assume that, okay, you have two colors and I'm going to refer them as lower color and upper color, right? Simple as that. So these are in HSV format. So these are two HSV values, right? So this is basically like two colors, right? So how these two colors are obtained, right? I will explain it later. Let's assume, okay, using these two colors, we can detect the blue color lead, right? The blue color lead we can detect. Let's assume like that, right? So what we are going to do now, we are going to like actually now these are two colors and these are considered as the lower color and the upper color, right? So what we are going to do, we have a function in OpenCV called inRange, right? We have a function called inRange in OpenCV. So what we can do is we can provide the HSV image and then we have to provide the color range, right? The color range. So when you provide the color range, right, like the lower color and the upper color, then this returns a mask, right? Actually this returns a threshold image, right? This inRange function, this inRange method returns a binary image. That means a black and white image. So I'm going to refer it as mask. Now there's no special meaning here, right? But I'm giving it as a mask since it acts as a mask, right? So that's why I call the image as a mask, but no specific meaning. You can use any other name. But anyway, let me show you the output, then you will understand what happens here, right? So I will show you the mask as well, right? So this is the mask, right? So you can see this is the mask, right? So you can see that clearly, right? So you can see that clearly the blue color lid is kind of highlighted here, right? So what has happened here is like all the other, right? All the other colors in this image are neglected, or we can say they are converted to black, right? So they are replaced with black color, and only the blue color, not exactly all the blue, but you can see that there is a, right? So there is a like this blue color is not detected, but we can detect that color as well. We will discuss about that later. But anyway, you can see the blue color is converted to white and all the other colors are converted to black, right? So this is simply color segmentation, right? Now, if I ask you a question now, if you can get this image, I mean, let's assume that I have provided this image to you. Now, from here onwards, can you like detect this blue, I mean, can you detect blue color lid in this image, right? Can you do that? Yes. So if I provide you this image, right? I mean, this image, can you then detect the blue color lid from here after? Like, I mean, what I'm asking is simply, can you draw a rectangle around this like this? Okay, this is the blue color lid. Can you do this detection? Yes or no? Yes. If I'm going to provide you this one, right? This image. So can you detect the red color lid? I mean, the blue color lid. Is it possible? Yes or no? I mean, detecting in the sense like, can you draw a rectangle around that? Yes. So if it is yes, can you say me how, right? So can you say me, okay, you have this black and white image, then what you can do in order to detect that blue color lid? Yes, any idea? What you are going to use? Yes, exactly. So you can use the what operation. We learned it yesterday. Yes, we learned it yesterday. Yes, using what? Huh? We can use what? Huh? Yes, we can get XYWH. So how we are going to get by X? I mean get XYWH. We have to apply what? Huh? Yes, can you remember? Yes, find area. Yeah. So what I'm expecting is like we can apply the contour operations, right? Contour operation, right? We can find the contours, right? Then we can find the contour and then we can draw the rectangle, right? Can you remember we did this last time, right? So from here onwards, you can do it, right? Understood? Got it? So that's how we are going to do it. Now, what happens here? I didn't explain that, so let me explain it now. Now, what happens here? I mean, this in-range function, what it does, right? This in-range function, what it does, it simply, like this is again pixel-wise operation, right? The pixel operation. So what it does simply, it goes through the whole image, right? It goes through the whole image, right? I mean, whole image in the sense it's going to go through each and every pixel in this image, right? So it's going to go through each and every pixel in this image. Then what it does simply, then it's going to, right, check whether, like it's going to go through each and every pixel and it's going to check the pixel value of each and every pixel, right? So it's going to check the pixel value of each and every pixel and check whether that pixel is in this range, right? Whether that pixel value in this range or not, right? So if the pixel value is in this range, then that particular pixel will be replaced with white. If the pixel value is not in this range, that will be replaced with black. Understood? Right? Got it? So again, let me explain, right? So we are going to like, I mean, when this in-range function is applied, what it does, it's going to go through each and every pixel, right? So it's going to go through each and every pixel in this image, right? Each and every pixel in this image likewise, right? I mean, it's going to go through each and every pixel and check whether that pixel value is in this range, right? So if it is in this range, that particular set of pixels, right, which the pixel values are in this range, those particular pixels will become white, and the other pixels, all the other pixels, if that pixel value is not in this range, that they will become black, right? So that's how we are going to get this image. Understood? Right? Understood? Got the idea? Right? So then you can understand, okay, so in order to do the color segmentation, what you need to have is like you need to have the lower color and upper color, right? The lower color and the upper color of the image that you are going to, I mean, the lower and the upper color, right? So you need to find, let's say you want to detect an object, right? You want to detect an object based on the color, let's say, right? So if you want to detect the object based on the color, what you have to do simply, you have to find the suitable, right? Suitable lower color and the upper color for detecting that particular object, right? So if you can find that one, simply what you can do is you can, right? You can simply detect that object, right? Okay. So let me now, okay, now I got these values are from somewhere, right? So I mean, these value, right? I explicitly got these values, right? So I just ask you to assume, okay, these lower color and upper color can find the range, I mean, can detect this blue color. So I ask you to like assume that, right? I ask you to assume that. But what I'm going to do now, like, shall we do it for another example, right? So shall we do it for red color? Huh? Shall we do it for red color? Or right? Shall we do it for I mean this yellow color, right? Shall we do this for this yellow color, right? So how we are going to do that, right? First, what we need to do is we need to first find the, right? So first we need to find the right? First we have to set the upper color, right? First we have to set the upper color, right? So how we are going to set the upper color, right? So it's quite simple. Now I'm going to show you how you can define these two colors, right? How you can define these two colors, right? Based on the object that you need to detect, right? So let's say that you have a particular object to detect, right? Now I'm going to explain how you can define the lower color and upper color for the object that you are interested in detecting, right? Now these two values, we got these two values from somewhere, so it detects blue, right? So now we are going now we are going to see, okay, for a custom object, how we can define these two colors, lower color and upper color, right? So this is how we are going to do. First you have to define the upper color. That's the task number one. You have to first define the upper color. So what you are going to do, simply you are going to go to this one, right? And you have to have the reference image in the sense, now you have to see this image first, right? Then you have like have an idea about your color that you are interested on. So this is the color that you are interested on, right? So now what I'm going to do is I'm going to come back here, right? Now can you can you give me the value, right? So can you give me the value, or can you guess the value by looking at this H circle, right? The hue value circle. Can you guess me the, like, roughly, can you guess me the value of this lid on this H value? So if you represent it by a H, I mean the hue value, can you roughly give me a value for the no, I need only the H value, right? So I need only the H value. We'll discuss about like S and V later, but yeah, H value others. What do you think? Huh? Yes, other, your guesses quickly. Yes, others. Yes, just guess the value by looking at the hue values. Guess the value for this lid, right? A closer value. Yeah, 25 to 35. Okay, right? So let's see now. This is somewhere like 27.5, right? So this is the same. I mean, this is in the middle between, I mean, in the middle of 0 and 45. So you can guess that this is something like 27.5, right? So I think the color is somewhere here, isn't it? Right? So we can say it's like 30 or 35, right? 30 or 35, right? So what you are going to do, right? What you are going to do is you are going to like, okay, so let's assume now this is like what the color you need. Like, let's assume, okay, this is the color you need, the exact color, right? So this is something like 30. Why I say like this is 30? Now in the center you can see, right? The center is like 27.5. So this is like 30, right? So what we are going to do then, right? What we are going to do, we are going to get like, okay, our exact value, we can assume it's like 30. So what we are going to do is we are not taking exact 30, but we are going to like get like bit more than 30, right? So what we are going to do, okay, our value is 30, so we are going to get bit less than that, right? So like we can say 35 or 40, right? 35 or 40, right? So for the time being, I'm going to get like, yeah, 35 would be fine, I think, 35. Or 40 also would be fine. This is like trial and error, you have to see it, right? So for now, we will go with 35, right? So then what we are going to do, okay, H value, we are going to set it to 35. How we set it to 35, right? Or we can go with 40. We will go with 40, right? So how I set H value to 40, I just like, I mean, it's something we can't exactly say, but I'm going to look at this hue circle, and I'm going to find a very closer value to the color that we are, the closer H hue value for the color that we are interested on, right? So then, like, let's say that value is 30, so we are going to get more than that value, right? A bit more than that value. So that's why I selected 40, right? So that's what we have to do. Okay, you got 40. Then what about S and V? S and V, they are not, we are not going to worry about them. We are going to put like 255, right? 255, right? So this is like both S and V, we are going to make 255. So this is how we are going to set the upper value, right? So this is not the lower value, but this is the upper value, right? Now, always S and V will be 255 in the upper value, right? So don't worry about S and V. We have to worry about only H, right? S and V always will be 255, right? Got it? So then our upper value is defined, right? So then what we are going to do, right? So then what we are going to do, right? Then you are like, okay, so our value, I will write it here, okay, somewhere 40, 255, 255, 255, right? So this is the S, I mean the H, sorry, the upper value, right? So this is the upper value. Then what you are going to do, you are going to then go to this code. Which code, right? So I am going to go to this find in the color range code. So what that code is, I'm not going to discuss this code with you, right? So it's something like, in order to find the color range, so the functionality of the code is not important, right? So I'm not going to explain it. It's something to do with the graphical user interface. So don't worry about this code, the finding the color range code, right? So what we can do, like, so the upper value we define it ourselves, right? So the upper value, right, we decide it ourselves, right? So then in order to find the lower value, right, so we need the two values, right? Upper value and the lower value. So upper value is now defined. In order to find the lower value, what we are going to do is we are going to use this find color range code, right? So what you are going to do, you have to provide the path that you are interested on, I mean the image that you are interested, right? Then what we are going to do, right? Then we have to provide that path here, right? So now this is nothing the find color range code, right? So here you are going to provide the path that you are interested on, right? Okay, got it? So then what you are going to do is simply, right, you are going to you are going to simply what? Then you are going to provide that particular value here, 40, as the upper color in that code, right? 255 and 255. So you are going to provide that upper color here, right? Understood? So then what you are going to do, then you are going to run this code, right? So I made two modifications here. You have to provide the image that you are working on, then the upper color you decided, then what you need to do, just run this code. Which code? Find in the color range, that code, right? So then run it. Then what you are going to do, what you are going to get, you are going to get right, you are going to then get something like this, right? So you are going to get something like this, right? So this is nothing but when you run this one, like change in the image name and also by changing the upper color value, then if you run this one, you are going to see this kind of output, right? Now what you are going to do, now first starting from the H, you are going to increase the H value, right? So how we are going to determine the value, right? I mean, how, up to what value you are going to increase this, right? So you are going to start from H, right? So carefully listen, I mean, carefully note that we are going to start from H and we are going to then increase the H value until like if you, I mean, if you are going to see that the image, I mean, the object or the color that you are interested on, if that color is also, let's say, it's also going to become black, right? That object also, when that object also starts, when that object starts to become black, then you have to stop, right? So here you can see, like if you go beyond 90, right? So if you go beyond 90, you can see that it's fading. I mean, it's like right, the black, that area becomes black, right, step by step. So therefore, like we have to stop from here, right? So that means, okay, so this is the H value, right? This is the lower H value, right? Then what you are going to do, right? Then what you are going to do, you are going to then go to S and V, right? First you are going to go to S and start the same procedure and continue until the yellow color starts to become black. Okay, you can see, right? So from this onwards you can see, right? So it's becomes black, right? So so what you are going to do, somewhere here we can stop, right? See, so I can stop around like 150, right? So this is like the S value. Then what you are going to do, then we are going to move on to the, right, the V value, right? So then you are going to start like, so then you can see somewhere here, okay, right? Somewhere here you can stop it, 107, right? Right. So now you can see, like, so there is some issue, right? So now these right, these values are also detected. Can you see? I mean, right, these some like unwanted areas are also detected, see, right? So I think that's probably like green color, right? So that means like the green color. Now if I make it back here, right, so you can see they are green color, right? So if you take the original image, you know that they are green color, right? So can you remember, can you understand why this green color is also detected, right? Why? The thing is that the value that we selected, right? Value that we selected is what? 14, I mean 14 in the sense the value that we selected for the upper value, right? So you can see upper H value, we selected 40, right? So why this is detecting, I mean, why it's going to detect this green color area as well? Why? The value that we selected here is bit right, bit high, right? So 40 is like green. So you can see when you go somewhere here, it's green, right? So I think if you reduce it to somewhere like 35, right? So if you reduce it to somewhere 35, that green color area won't be detected, right? The upper value we selected is too much, I think, right? So it's like we have selected some like green color, right? So that's why these green colors are also detected. So shall we check it? Like we can, if you can provide 35 here, then probably those things will get removed, those, right? So we are going to run and see, right? Probably. Right, so can you see now it's better than the earlier one, right? Better than the earlier one, right? See? So I think now we can reduce it further more, right? I mean, like, so if you go like 33, so 30, let's say we go with 30, let's say. I think this would be better. See, much better, right? Almost all the green colors are not detected now, right? Got it? So we can modify then this value, right? So we can modify this value. So we can go with 33. So now you can see this is, I mean 30, right? So this is totally like trial and error. We can check these values, right, by changing, right? But I hope you understood, right? So by looking at the, right, so by looking at the object color, you can detect the upper value, right? I mean, you had only defined what? You had only defined the, yes, the only the H value. S and V value are like they are already 255 and 255. Then apply that image into this code and you can find the lower value, right? So you know how to do it. First change the H value and do it, I mean, increase the H value until you are going to see black patches in your interested object, and then stop it. And then you are going to increase the, similarly, you are going to increase the S value until black patches are visible on the object you are interested on. Then stop it, then go to the V value, increase it up to black patches are seen on the object that you are interested on, right? So then that's how you are going to get the lower value, right? Now it's nothing like, I mean, it's quite simple. Now if you provide these values here, right, you are going to see that your, right, your, I mean, see, right? Now what I told you, like then what you need to do simply, right? So now any idea how we can detect this thing? I mean, how we can draw a rectangle around this, right? So it's quite straightforward. You can apply the contour operations and find the x, y, w, h. Then you can, right, get the rectangle around this, right? So that's quite simple, right? Okay, so we'll do it in another example, not this one, right? So now we'll go to our right. We will go to our the project today, right? So our today's project, right? So now you can see in your samples folder, right? Not the samples folder. You should be in the day 3 folder. Not exactly day 3, but day 2, in the day 2 folder, right? Day 2 folder, you have right? You have this folder called plants, right? You have a folder called plants in the day 2 folder. So if you go there, you are going to see temporal image in the sense, like you are going to see some images obtained day by day, right? So it starts from day 5, day 6, 8, right? So we are going to, I mean, here it's about the right. I mean, we are observing here the growth of this plant, right? So we are observing the growth of this plant, right? So you can see from the day 5, right? So each day an image is captured, so you can see the growth of the plant, right? So now this is some, I mean, this is actual application, and this is something like we can do for this what the greenhouses, right? So without entering now in greenhouses, there are these control mechanisms, like depending on the growth of the plant, the water level, right, and the humidity, temperature, carbon dioxide level inside the greenhouse is they are controlled, right? So those parameters are controlled. So in order to control them, what you need to do is you have to all continuously measure the growth of this uh, plants, right? Understood? So therefore, there should be like, I mean, a person can go always, right? A person can go always and measure it day by day. So that's another application. I mean, that's how we are going to do it practically, right? I mean, a person can go each and every day, and let's say that there are 100 plants, right? So in the 100 plants, so we have to measure day by day the height of each and every plant, right? Each and every plant. So that's not practical. You can understand, right? So it's not practical. Therefore, like we can use without doing it manually, right? So without doing it manually, what we can do is we can use this kind of image processing technique and measure the right, measure the height of this one, not I mean manually, but using a camera we can measure it, right? So that's the application, right? So we will implement a simple image processing, I mean a code in Python in order to do that, right? So therefore, first what we need to do, right? Now our final goal, right? Our final goal is something like this. Um, right, to do something like this. So this is our final target, right? Understood? This is our final target. So in order to do that, right, in order to do that, now let me ask you a question. So in order to do that, what should be our first step? Yes, can you guess what's the first step? Yes, yes, exactly. We have to define the color range, right? So that's what we need to define, right? Color range. So let me now when you are going like, okay, I'm going to get this plant, one of the plant images, right? So when you are going to define the color range, what should you define first? Is it the upper color or the lower color? You know these things now. Yes, upper color or lower color. We just discussed this now. Yes, upper or lower? Upper, right? Okay, now can you suggest me a value by looking at these two images? Yes. For the H, right? For H, can you suggest me a value? 40, somewhere 40. Yeah, yes, exactly, right? Yeah. So it's something like yellowish green, right? So it's a yellowish green. So we can say somewhere here. So shall we take 45, right? right? So I think 45 would be fine. I mean, the color is somewhere here, right? So shall we take like 40? Yeah, so the color is somewhere here, I think, this color. So we will take 50, right? So we will go with 50 and see whether it's going to work, right? 50, right? Okay, so what you need to do, you have to define it. So, okay, 50, we will go with 50, right? Then you are going to go, what you are going to do, you are going to get a sample image. I mean, right? A sample image and go to this fine color, yeah, right? So you are going to get this image and you are going to go to this fine color image and I mean fine color range, and then you have to replace this, right, with your image that you are interested on. Then here you have to provide the upper color. So we agreed to 50, right? So we agreed to 50. Now what we are going to do, 50, 255, 255. I mean, S and V are, you know, right? So they are, S and V are fixed, right? So now what we are going to do is, we are going to run this and you are going to get something like this, right? So you know the procedure now, right? You are going to change the, now let me get the upper color first. Upper color is 40, I mean 50. Right? Then the lower color you have to define now, right? So you know the procedure, start from H and change the value, right, until this point, here. Now you can see, okay, your plant is also black color patches are shown in the plant. So that's where you are going to stop, right? So I'm going to stop at 26, right? Then the S value, right? So the S value, then we are going to change, right? So you can see if you do further, right? So at this moment, you can see that the image also becomes, right? So I think 35 would be a good value for the S, right? Then what you are going to do, simply you are going to now change this V. So I think you can go up to this kind of a value, right? So I think that would be a good value, right? So I think we can, right? So I think we can go with this, right? 115, right? Okay, so the upper color and the lower color are defined, but you can see, right? So you can see that there are tiny little this kind of, right, unwanted patches are also detected. So can we get rid of these things, right? Can we get rid of these things? Surely you can. How you can do, like you can get the area and you can neglect this small area, so you can later detect only the, right, the plant, right? Got it? So how we are going to do that? Simply, right? How we are going to do that? Now our things are defined, so we will check these values with our images, right? So the upper color we are going to go with 50 and the lower color is somewhere 26, right? And we will put like 30 and 115, right? Okay, so shall we see the output? Or we can, I think 35, it was 35, right? Okay, so shall we run it and see the output? Yeah, so I'm getting an error here. Right, so let me run it again. Yes, right. So it's clearly detected, you can see, right? It's clearly detected, but some unwanted things are also there, right? Some unwanted things are also there, but we will get rid of those things later, right? So shall we apply all the images and see whether everything is detected now, right? D5 will apply the smallest one. right? Yeah, it's not, I mean, yeah, somewhat detected. No, no, everything is detected, right? So you can see this is the smallest one, right? And we will apply something like day 8 to see whether it's detected. Day 8, yeah, detected, fine. And shall we go with like day 14? Yeah, it's clearly detected, right? Some unwanted things are there. I I accept that, yeah, there are unwanted things, but we will get rid of those things, right? Now here onwards, what you can do is, right? Now here onwards, right? So now, can you tell me the next step? What should be the next step? What should be the next step? Yes, contours, exactly, contours, right? So you know all the code. So what you have to do is you have to just apply them, right? So then what you are going to do, we are going to apply the mask to the contours and we are going to find the contours, right? So we'll find the contours and then you can, if you like, you can draw the contours and see, right? So you can draw the contours and see. So I'm going to draw the contours in like, I'm going to draw all the contours, right? I'm going to draw all the contours and I'm going to draw them in the original frame, right? So then let's see the output. Yeah, so you can see the contours are drawn, right? Contours are drawn now. So then what you are going to do, right? So we have to get rid of these unwanted detections, right? So what I mean by unwanted detections, right? So these contours you can see like they are also detected, right? So we want to get rid of them, these small things, right? So you know a method to do that, right? So what you can do is you can go with the contour area, right? So you can go with the contour area, right? And instead of drawing all the contours, I'm going to draw the contours which are like, I'm going to find a particular value later, right? Right, so 200, I mean, we will go with like 500 first, right? So then see whether it's working or not, right? So let's see. Yeah, now you can see it's fine, right? So 500 it works, right? For 500 it works fine, right? So all the other, now let me like use another color. This is a bit confusing, so let me use the red color to draw the contours, then you will understand, right? So now you can see all the other contours. Now here, these are all the contours that detected, but now we have got rid of these small items. Why? We use the area to segment them, right? So using the area, now here we are only referring to the contours which has like at least 500 greater than 500 area, right? So from that uh, 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 right, so that's where um, right, so right, so you can get the output, right, like this. Then what you can do simply, right, so you can do the bounding and right, so you can get the boundaries, right? So XYWH, and you can get the, finally you can get the XYWH, and you can draw a rectangle around it, right? So like this, right? So then you need to measure the height, right? So that's our ultimate goal. You know, our ultimate goal is to measure the height, right? But thing is, like we can't get the exact, I mean, right? So we have already found the height. Any idea where the height is? Right? What's the height? Yes. Yeah, exactly. This h, right? So this h is the height, right? This h, right? But the thing is, this h is in, like, what is the unit of this h? Yes, this is in pixels, right? So we can't exactly get we can't get exactly like millimeters or centimeters. We have to get it from pixels. We have a method of converting pixels into millimeters. I will explain it later, but for now it's coming in pixels, right? So how you can do it, what you can do is you can put this as a text, right? So how you can do it, you can put it as a text. So we have something called put text, a function called put text, and using this put text, what we can do, we can place text, right? So we have to mention where we are going to play, I mean, in which image we are going to place the text, right? So then what you have to do is you have to then provide what's the text is. So I'm going to print like height colon plus. So I'm going to add h, h is a float value, I mean an integer value. So you can't directly add it to a string. So you have to convert it to a string and add. So it will be shown like height 38, height 100 likewise, right? So then you have to provide the place where your text is, I mean, text is actually placed, right? So that means, let's say, okay, we are going to provide like 1000, right? So if you provide the place like this, then it will show like this. So whatever the point that you are going to provide here will be taken as this left side bottom corner of the text, right? So then you have to provide that thing. So I will provide yeah, I'm going to provide the top of the rectangle. So you know that we have a rectangle here, right? So we have a rectangle. So we have the XYWH, right? We have here XY and WH. So I'm going to say, okay, at XY. But what will happen if you put it at XY, right? So the right, so XY is this point, right? So the top of the rectangle. So if you put it here, what will happen is like you won't see the, I mean, it will be cropped with this rectangle. I mean, the lines will, yeah, we will do it like in that way and see the output first. Right? So then you have to provide what's the the font you are going to use, right? So there are several fonts available that you can use. So you can see that list in the internet, OpenCV supported fonts, right? So these are the OpenCV supported fonts. Sorry. So there are few fonts available, so you can check them, right? These are the font: Hershey, Simplex, Hershey, Plain, Duplex, Complex, Triplex. Likewise, we have many fonts available, right? So here is example you can see, right? So how you get, you can you have different fonts now: Times New Roman, Arial. Those are not available here. So you can provide the text like cd dot font Hershey Simplex, right? So this is one of the fonts available. You can duplex, complex, triplex, small, simplex, complex. Like these can be also you can like try them out, but I'm using this simple font, right? Then you have to provide the font thickness, right? Sorry, you have to then provide the font scale, right? I will put 1 and I will later explain what font scale. Then the next value is font thickness. I will explain those things in a minute, right? So we'll run it and see whether, yeah, you can see now, unfortunately we can't see it, and I forgot one parameter to provide, right? So that parameter is the color of the font, right? So the color of the font I forgot. So the color of the font you have to provide in between the font scale and the font thickness, right? So I'm going to use white, let's say, right? So if you run this one, you can see that height is not visible, right? So let me take the h, I mean, let me change the y value. So I'm going to add like 20, y plus 20. So I'm going to take it bit downwards, right? So let's see now. So I think we have to take it like not 20, like 30, and we have to also increase the x value as well, like 10. So then you can clearly see it, right? Okay. So that's I think that's not clear. So I will do something like this. Yeah. So shall we take it to x plus w, right? So the bottom x plus w plus something like 10, right? So then it will be yeah, somewhere here. So it will be fine, right? Correct. Okay. So then like here, what's font scale? So this is called the font scale. So when you provide 1, so that's the default size, right? So you can then provide the scale, like, I mean, if you provide 0.5, that is basically half of the earlier one, half of the earlier size, right? So if you provide 2 here, that's twice of the earlier size, right? Got it? So likewise, you can provide the scale, not a font size, like 12, 14, 16. It's not a font size, it's a scale. So this is the default size, right? This is the default size. And you can provide any other scale and like make it larger or small, right? So we will, yeah, I think 1 is fine. Then this is the thickness in pixel. Like, I mean, if you increase it, the thickness of the font increases, right? The thickness of the font increases, right? That's what happens. That's to do with the thickness. That's something to do with the thickness, right? Got it? Right. So that's it, right? So now we have done it for this kind of image. So everything is fine, right? So one last thing. So how we can convert it to millimeters or centimeters if you need, right? The thing is, like, we can do it only for, and I mean, if you can convert it using a single camera, right? So if you are using a single camera, you can assume, like, let's say the camera is right, when the camera placed like, we are going to assume that always the camera and the, like, the plant, the distance between the camera and the plant are always constant, right? I mean, throughout, I mean, in all the days, right, we are not going to change the position of the camera. So we are going to assume, okay, the camera and the plant, the distance between them are constant, right? So if you do that, what you can do is you can get a ruler, right? For example, you can get a ruler and you can go inside the greenhouse and measure the actual height, right? The actual height, right? Then what you can do is you can get and you can show that image into the camera and you can get the height shown in pixels, right? Then you can get the height shown in pixels in the computer by running this code, right? So then you are going to get this ratio, right? You are going to get this ratio h divided by h, right? Then for an unknown image, right? For an unknown image, for example, now let's say that you have a new image here, right? Unknown image, right? So let's say, okay, you don't know this one, right? Okay, so now the pixel value is coming in, right? Pixels, I mean, the distance is coming, I mean, the height is coming from pixels. So you can multiply that pixel value and you are going to get the distance, I mean, the height in millimeters, right? So you have to have a known plant height and you have to measure the height shown for that plant in the code and you have to get the ratio. So this is that ratio. Then for unknown height, you can multiply that height from this one and you are going to get it from millimeters, right? So that's a simple method of doing it. Got the idea, right? I hope you got the idea, right? Okay, right? Good, right? So then what you are going to do, right? So I have a video now. This is not a real video, right? This is not a real video, but this video is like image, the video that we right, like artificially created, a synthetic video, right? Like I wanted to show you that like if these plants are going on a kind of belt, right? Right. Right. So if the camera is, or let's say camera is moving, how we can do that? So it's nothing, right? The same code, the same exact the same code, we are going to apply it for this video, right? That's what we have done, right? Nothing else. So then you are going to see the output like this. Let me first. Right, see, so you can see it's detected, right? I think I have resized it. Right. So that's how you can do it for a video, right? Right. So that's a complete project, right? Hope you got the idea, and you can see that quite interesting, right? And we have used very simple, like the novel thing that we used here is only the color segmentation, right? So the like color, based on the color we have based on the color we have segmented the tree, I mean the plant, right? Other than that, we use the contour operations and the thresholding, and also like contour area, right? So those things we learned yesterday, right? So we combine what we combine this color segmentation with contour operations, and we got it worked, right? Hope you got the idea, right? Okay, right? So hope you are good with that project, right? So any issues you have, or any doubt or anything you need to clarify, get clarified. Yes. Okay, seems you are fine with that, right? So now we are going to go into the next major topic, right? Neighborhood operations, kernels and filters, right? Neighborhood operations, kernels and filters, right? Okay. So right, so this is the second major topic that we are discussing. What's the first major topic, right? What was the first major topic that we were discussing? Any idea? The point operations or pixel operations. So that was the first major topic that we were discussing under this image processing workshop, right? So now we are going to go into the next major topic of our workshop, that is neighborhood operations, kernels and filters. So this is also a very important topic, right? So before going on to this, right? I mean, before explaining this, I will show you a example, right? I will show you, I will show you what this neighborhood operation is about and how it is done, right? So I will show you them using some examples, right? So then you will understand what actually we are going to do here, right? So in order to do that, so this, I have a demonstration, right? So I have a nice demonstration. So using that demonstration, we are going to understand the neighborhood operations, right? So in order to do that, here we are going to get this example. Like there is a nice demonstration, a visualization in this link. So what you have to do is you have to just press this link, then that thing will be open like this. Right? Okay. Right. So now I will explain this, but I'm not going to first like explain what, right? So don't get confused. I'm not going to directly go and discuss what's neighborhood operations and what is kernel, what are filters, right? I'm not going to directly go into the explanation. Instead of that, what I'm going to do, right? Instead of that, what I'm going to do is, right? Instead of that, I'm basically trying to show you what neighborhood operations, right, and kernels. So I will show you an example, then you will understand what I'm trying to explain. I mean, what I'm trying to explain under neighborhood operation. So we will see the demonstration first, right? We will see the demonstration first. Okay, so what you are going to do, don't get confused here. Let's assume that you have a, right? Let's assume that you have an image like this, right? An image like this. Got it? An image like this. And like, if you have an image like this, you know that there are pixels, right? So that's something that you already know. There are pixels, right? Then what you need to understand, right? So we can see this kind of a nice image, right? So we can understand there's a human face, right? A human face, like we can understand the color and we can assume, okay, that there's a human face, right? But actually, we see that, but the computer actually sees something like this, right? The computer actually sees something like this, right? So it's going to see set of numbers. So assuming that this is a gray image, right? Assuming that this is a gray image, the computer is going to see some numbers like this. So that's what's going to happen simply, right? It's not going to identify colors, so it's not going to identify like pixel. I mean, it's not going to identify pixels like us, right? So it's going to just see set of numbers, like it's going to consider this image as an array, right? So that's what I want to highlight. It's going to consider this as a matrix, right? So that's what happens, right? So then what I'm going to do, so this is the image, so this is the face image actually, like this is what the computer sees, right? Okay, so then what I'm going to do, I'm going to get a matrix, right? Another matrix, right? So this time this matrix is a like bit small, right? A small image, I mean, it's a small matrix, right? So you can see like we are going to get a matrix like this. Now don't worry about these values. What are these values? Like 1 0 minus 1 2 0 minus 2 1 0 minus 1, right? So don't worry about those numbers, right? We will discuss about those numbers soon. But let's assume that, okay, you have this set of numbers, right? Like there are 9 numbers and you can see that this is a, like simply it's a 3 by 3 matrix, right? And this matrix, we are going to call it a, like we are going to identify this using a name. I mean, name in the sense like a special name. We are going to provide a special name for this, and that is kernel, right? So we are going to name this as a kernel. Why? Since it is 3 by 3, no. Since not like it's not because like it's a 3 by 3 matrix, no, not that, right? So we are going to name this as a kernel. Why? I will explain it shortly, right? Why we are going to call it as kernel, I will explain it later. Soon I will explain it. But let's assume, okay, there is something called kernel, right? And kernel, don't get confused. A kernel is nothing but a matrix, right? Is it necessary to be 3 by 3? No, it's not necessary to be 3 by 3. We are taking a 3 by 3 matrix, but don't think that, okay, it should be always 3 by 3. No, it's not necessary to be 3 by 3. It's just a matrix, and we are going to especially give it a name like kernel, right? And it has some values and it can be changed. Now here we have some sample values, right? Got it? Okay. So then what we are going to do is, right? So what we are going to do is, we are going to get this input image, right? And then we have something called output image. Right? We have something called the output image as well. So then let's assume that we have two images, right? So the one image is the input image and the other image is the output image, right? So output image at the start, it is a pure black image, right? The output image at the start, it is a pure black image, right? Then what we are going to do, right? Carefully listen, right? Carefully listen. Sorry. Okay, right. Right. Okay, now it's like this, right? So what we have is we have a matrix I told you, and we refer this as a kernel, right? We refer this as a kernel, right? Then what happens, right? Then what happens? I'm going to get this kernel, right? So I'm going to get this kernel. What I mean by kernel again, this one. This is what you know as kernel. Right? Then what we are going to do, we are going to place this kernel, right? So can you see now here in this image, there are like 3 by 3 like red, like 3 by 3 red rectangle is there. Can you see? Now I'm talking about this, right? So here, see here, right? So I can like, okay. So you can see, okay, right? Can you see like 3 by 3 rectangle, right? So there are nine cells, right? 9 cells are there, right? Okay. So what I'm going to do now, you know that, right? Right. So here, let's assume that these three, right? So these 9 pixels, you know that those pixels, right? So these 9 pixels, right? So what I'm talking about, these three, I mean these 9 pixels, right? So you know that these 9 pixels, right? They have a value, right? They have a value in that pixel, right? So each and every pixel has a value, you know that, right? So the pixels that I highlighted here, also they also have a value, right? So they have 9 values. We have 9 pixels here, so they have 9 values there, right? So what we are going to do now, right? So we are going to now what we are going to do, we are going to get the kernel, right? So what the kernel, this is the kernel. So I'm going to get this kernel and I'm going to place that kernel on top of these 9 pixels, right? I'm going to place this kernel on top of these 9 pixels, right? So that's what I have represented, like, I mean, the kernel is represented by this rectangle, right? So here you can see this moving nine elements, right? So you can see this moving 9 elements that represents the, right? That represents the kernel. Simply that represents the kernel, right? Okay, right? Then what? Then what? Then I'm going to, okay, place it here as I mentioned, right? So now you can see here. Now carefully see this, right, the highlighted. Now I'm going to highlight it in red, right? So see this, right? So here what happened, right? Here what happens, I have placed the kernel on top of the pixels, right? So there are 9 pixels and I have placed my kernel on them, right? Then what we are going to do, right? So here you can see this. Can you see the red highlighted? I mean, I have draw a rectangle, right? The red rectangle you can see. So 206, 205, 247, 244, 261, 173, 192, 15475, right? Those values again 206, 25, 205, 247, 244, 161, 137, 192, 154, 75, right? So those values are the pixel values, right? Pixel values in the sense they are the pixel values of the, right, of the pixels which are, right, which are like which are governed by, right? So which are governed by this kernel, right? Sorry. And then you can see that there are like there are some values, right? So see the red rectangle. So 206 into 1, 205 into 0. Now that into, like, we have multiplied each and every value, right? So those multiplication is done with the corresponding values of the kernel, right? So you know the kernel is 10 minus 1, 20 minus 2, 10 minus 10 minus 1, right? So what we are going to do, we are going to multiply them with the corresponding kernel value, right? We are going to multiply with them the corresponding kernel value, right? So you can see, right? So what we are going to do, okay, we are going to multiply 206 with 1, right? So then we are going to multiply 205 with 0. Then we are going to multiply 247 with 1 and minus 1. So when we are going to multiply with 244 with 2, then we are going to multiply 161 with 0. Then we are going to multiply 137 with minus 2. We are going to multiply 192 with plus 1. We are going to multiply 154 with 0, 75 with minus 1, right? Likewise, so we are going to multiply one by one, right? So then you can see, if you multiply, then we are going to add them together, right? We are going to add them together, multiply. So we are going to take like weighted sum, right? So we are going to like take the weighted sum. So then that value will be, right? Then that value, what we are going to do is that value, right, is taken like this. And there is a like important thing, like all the values greater than 25, right? So if the pixel value you are getting is greater than 25, that, like, we are going to make that equal to 255, right? And if the value is less than 0, we are going to make it 0, right? So now here the resultant value is 290, right? 290. So that you know that is greater than 255. That is greater than 255. So it is actually considered as not 290, but it is considered as 255. Understood? The values less than 0, like, I mean the negative values, they are also considered as what? They are also considered as, right? So if you have a negative value, that is considered as 0, right? Got it? Okay, now we have a value here. You see that we have a value here. Right? Then what you are going to do now, you need to note that, right? You need to note that the input image and the output image are equal in dimension, right? The input and output images are equal from the dimensions, right? Right. So they are, I mean, dimension wise, they are equal, input and output image, right? But the output image At the start, output image is purely a black image, right? Now, what we are going to do, so you can see that we got a value like 290, right? But actually that should be 255, right? So that's 255. So this 255 is, you know, that it has a color, right? So what's the color? 255, what's the color? You know, it is white, right? So what we are going to do, we are going to get the white color, I mean 255, and you can see that, right? So the center of this, I mean, here, now this pixel, I'm going to use a different color, let's say. I'm going to use green, right? So now you can see that I have marked a pixel, right? So I have marked the pixel with a green cross, right? A green cross, I have marked a pixel. So you know that since the input image is equal to output image in dimensions, right? So you know that there is a pixel correspond to this, I mean, the output image, right? Okay, so the input image, I have marked the pixel with green color, right? So there is a same, I mean, since the input and output image are equal, I mean, dimension, so there is a pixel, a corresponding pixel for this yellow, I mean, a corresponding pixel for this green color marked pixel, there is a corresponding pixel in the output image as well. Understood? For this yellow color marked pixel, there is a corresponding pixel for that pixel in the output image as well, right? Got it? So what we are going to do, we are going to get that pixel in the output image, and we are going to assign the value here. Which value? Right. The value we are getting, what? The value we got is like, right? The value we got is what here? 290, right? So that we are going to get that 290, and what we are going to do, right? Then we are going to assign that value to the corresponding pixel in this image. See? Got it? Understood? Right? Got it? Right? So it should be 290, but we are making 290 as 255, right? So 255 is assigned there, right? Got it? Then what we are going to do, then we are going to, right? Then we are going to move this 1 pixel to the left, I mean the right side, right? So we are going to move this one 1 pixel to the right side, here, like this. Right? Now what the value, now what happens? Like, you know that the kernel value, I mean the pixel values change, right? Why? Now these are like 9 different pixels. Like earlier this was the like bounding pixels. Now we change, I mean we move the kernel to the right side a bit. So now the pixels are also changed, right? So you can see the pixel values got changed, right? Now when we do the same operation, we are going to get a different value. You can see it's -242, right? Now what we are going to do, we are going to get that corresponding pixel. What I mean by the corresponding pixel, like the center pixel. So this should be the center pixel, this one, right? So now what we are going to do, now here we were at here, right? Now we are going to select the corresponding, I mean the center pixel, right? The center pixel of this moment of the kernel, right? and we are going to select that corresponding pixel of the output image, and we are going to assign -242. That means actually we are going to assign 0, right? So then what will happen? You will see something like this. What? Right? Got it? So then what we are going to do? We are going to move here, right? Understood? Likewise, we are going to do it for, right? Right. So we are going to go like this then, right? So that means we are going to go like this. See? Sorry. Right? Got it? So the same operation is done, right? Same operation is done, right? So what will happen? You are going to see something like this, right? Then what we are going to do? Then we are like, okay, let's assume that, okay, see, now you can see the, right? So now you can see the center pixel, right? The center pixel. Now, can you see in the output image, can you see the center pixel, the red color pixel, right? There's a red color pixel assigned here, right? See, right? The red color pixel, right? Here. So I mean here. Right. So you can see that. Right? So that's the center pixel of the kernel, right? Center pixel of the kernel, right? So we are going to always assign this resultant value like 290 to that center value, right? So we are going to move it and the pixel values change. So that's the resultant value, right? So we are going to assign it, right, like this. Right? Got it? Then what we are going to do? Then we are going to move to, right? So after going from here to here, right? So one row is finished. Now what we are going to do? We are going to move one row to bottom, right? One row to bottom, then do the same thing again, right? So then what will happen? You will see something like this. See? Then the operation will be done like this. See? Then what? We go to the next row like this. Right? So finally, you are going to see this output, right? Got it? So from here to here, like we are going to go step by this step, right? Then to the next row, next row, next row, next row, next row, right? So likewise, we are going to go, we are going to slide this. That's what this is called sliding. We are going to slide this kernel throughout the image, right? So we are going to slide this image throughout the image and slide this kernel throughout the image, and you are going to get something like this, right? So this is what we call the neighborhood operation, right? The neighborhood operation, right? Or the, we can say, yeah, the kernel operation we say, or the convolution operation. So there are many names like neighborhood operations, kernel operations, convolution operation. So any name you can use. And this particular matrix is called, right? Matrix is called what? The kernel. It's called the kernel or the filter. We can also call it as filter as well. Right? Kernel or filter. Now, the important point here that I want to highlight, right? The important point that I want to highlight here, like the next point that I want to highlight is that, like, when you change the kernel values, right? So when you change the kernel value, right? So let me use this set of value, or let me use this set of value. See, now by changing this kernel value, you can see the output image, the output that you are going to get can be changed, right? Right? See, by changing this kernel value, you can get a different output, right? Now, like if you see this image, right, the output image, what is there actually? I mean here, okay, let's say this one. What is there actually? Can you understand, right? So what is this? Can you understand what this image is about? I mean the output image. Yes? Anything? Huh? Actually, right? Actually, what this about, right? This is basically what it right. So it's like this. Now you can see something like it's like you can see it like a meaningless image, right? A meaningless image, right? A garbage image, right? So what I'm talking about, this image, right? But actually, what has happened here? So there is some feature extraction happened. A feature extraction. Why I say like feature extraction, right? Why I say like feature extraction? Now, what are the features that has been extracted here? What are the features that have been extracted here? So if you see, can you see that what? Now you may be wondering, right? Before telling that, I want to tell this. Now you may be wondering, okay, we have a nice input image, right? We have a nice input image, and we apply this something called kernel operation, right? So what we call neighborhood operation, right? So now let's see, okay, we had a nice image, right? So we have a nice image. Then what we do? We are going to apply something called neighborhood operation or kernel operation. Then what we are going to do? We are going to get this dummy garbage image, right? Meaningless image. So what's the purpose? I mean, what's the big deal about this neighborhood operation or this kernel operation? So is it for getting this kind of a meaningless image from a nice image, nice meaningful image? After applying the kernel operation, we are going to get a meaningless image, right? A garbage image. So what's the purpose of this kernel operation or the neighborhood operation? But if you see clearly, you can see that from this input image, there is a feature extracted, right? Feature extracted. So what's this feature, right? Can you see like it's detected, right? So it highlights the edges. Can you see that? It highlights the edges. See? What edges? Right? It highlights the vertical edges. Can you see? Vertical edges. It highlights the vertical edges. See? 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 Got it? So the kernel operation or the neighborhood operation, it can be used for feature extraction. So what's the feature that we have extracted here is vertical edges, right? So now we can change these values, right? So and we can change it like, right? See? Now what? Yes, any idea? Now, what's the feature extracted here? Any idea? Yes. What is the feature extracted here? Yes, the horizontal edges, right? So you can see, right? See? Right? So now we can change these numbers, right? So the where is see? Now what? Now what's the feature extracted here? Can you understand the feature extracted here? What's the feature extracted here? Now we apply -1, -1, -1, -1, 8, -1, 8, sorry, -1, -1, -1. So what's the feature extracted here? Any idea? Actually, this extracts the outlines of the image, outlines, right? Got it? Now, you should understand that, right? Now you should understand that these, right? These, I mean, this kernel value, right? So these kernel values, they have a power. I mean, power in the sense these numbers, they have a power, or they have a like ability of detecting a meaningful feature, right? Now, don't think that these numbers are just random numbers I use, right? So these are not random numbers, right? So these numbers that I use, they are not random numbers. They are like standard kernels, right? So let's see, let's uh, get to know about those things quickly. Right? Um, Sobel operators, right? The kernels that I use now, these are the two kernels I use for the horizontal and vertical edge extraction, right? So horizontal and vertical edge detection. And these kernels, right? So they are not standard kernel. I mean, sorry, they are not random kernels. They are standard kernels, and these are like made by, I'm introduced by Sobel, Feldman, Sobel and Erwin Sobel and Gary Feldman, right? So this is something that they have introduced in 1968, right? So long way back, right? And like, don't think that they got this randomly. I mean, 1, 2, 1, 0, 0, 0, minus 2, likewise. Don't think that these values are like, I mean, selected random, there's a mathematics behind, like, I mean, a math background is there, right? So they have used some derivatives, right? And some linear algebra and some derivations are there. So this is not a these are numbers are not random values. So they are like, they wanted, I mean, they wanted to extract edges, they wanted to detect edges. So in order to do that, they implemented the mathematical model, and that's how you got these two kernels, right? Otherwise, don't think that they are just random numbers. But anyway, we have many kernels like this. Now, don't get confused. This is not Sobel kernels, right? I mean, these two are the Sobel kernels, right? These two are the Sobel kernels that we just use now. But this operation is known as the neighborhood operation, right? So this operation is known as the neighborhood operation or the kernel operation, right? This process is neighborhood operation or kernel operation. But what I wanted to highlight here, right? What I wanted to highlight here is that like the kernel that we are going to use now, the neighborhood operation is operation, but the kernel that, I mean, with the kernel that we are going to use for this operation, with the kernel that we are going to use for this operation, the feature that going to be extracted get changed, right? Now this is, I mean, the operation is the same, right? No matter what's the kernel, the operation is the same, right? So the same operation is done. But when we change the kernel, the output that we are going to get, that means the feature that we are going to get extracted, gets changed, right? Got it? Understood? So different features, I mean, different kernels are there for extracting different features, and Sobel kernels are one of them, right? Sobel kernels are one of them, right? So these are the Sobel kernels, and there are some other kernels as well, Laplacian kernel, right? So Laplacian kernel, there are two Laplacian kernels available, right? One is for One is for sharpening and the other is for outline detection, right? One is for sharpening and the other one is for outline detection. I think this is for the outline detection and this is for the sharpening, right? Got it? So we also use this, right? So there is always a mathematical background, right? So if you are interested, you can investigate this mathematical background. So there is a mathematical background. Otherwise, this is not the total. These numbers are not random values, right? So sharpen now. This is the kernel, the Laplacian kernel that we are going to use for sharpening, and this is the Laplacian kernel that we are going to use for outline detection. Got it? So these are like those numbers are taken from some research, right? And also there is a mathematical background always, right? So this can be used as I mentioned, right? Right. So image sharpening like this, right? And outline detection, this can be used. Okay. Right. Got it. So then yeah. So then we will move on to a code, right? So now I hope you understood what neighborhood operation is about, right? So like I show you a example, I mean example in the sense like a demonstration, right? So now I'm going to show you how it's done actually in Python code, right? So what we can do is we can get the image directly loaded, right? So I have a sample image, right? So I use this sample image for test these things, right? So this is the sample image, right? So what I'm going to do, I'm going to load it, right? And it is shown here, you can see, right? Then that image, I'm going to convert it to gray, right? That image, I'm going to convert it to gray color, right? Right, to the gray color. Then what I'm going to do, I have to define the kernel. Now this is the Sobel kernel, right? So kernel is like a NumPy array and it has like 3 by 3 values, right? Got it? Then what we are going to do, right? So we are going to apply this kernel, right? Apply this kernel like the neighborhood operation, right? So that what is neighborhood operation, right? So the neighborhood operation is just nothing but this. This is called the neighborhood operation or the kernel operation. Which one? This one, right? Taking the kernel and going through each and every pixel. I mean, going through the image is called the neighborhood operation or the pixel. Neighborhood operation or the kernel operation. Now, the thing here is we can do it in the Python code in OpenCV. What's the command? Filter 2D, right? And we have to apply the gray image and the kernel. Then the kernel operation will be done. Then you are going to get the output. We call it a kernellution. So this is the output you can see, right? Now this image is a perfect example where you can see like nice edges, right? So it has nicely detected this horizontal edges, right? And if you apply the other kernel, Sobel, now these are Sobel kernel, this is the X filter and this is the Y filter, right? So if you apply now, what I mean by X filter? If you want to like detect edges in this direction, right? Then that's called X, Y, not Y, but Y. Like if you want to detect this edges, right? So that's like on the x-axis, right? So this is x-axis. Right? So if you want to detect these edges, that's in the y-axis. Right? Got it. Understood. Right. Okay. That's what those two are about, right? Understood? Now, if we apply the Laplacian kernel, probably, yeah. So you can see this is Laplacian kernel. So you can see the outlines, right? Outlines of the image, right? Now you can see that these kernels are having a these kernels are having a like it's there's a magic, right? I mean, magic in the sense it can extract something, right? Now, shall we apply our own? I mean, own in the sense, right? Own in the sense, shall we apply uh, like our own one? Own one in the sense, huh? Some random numbers, let's say, right? Okay, so I'm going to add some random numbers. I don't have uh, like these are total random values. I don't know what. So let's see the output. It's a total black image. So I think we have to do some modification. All right. I think too much of negative values here. That's why. Yeah. So this is the output. So we can't exactly say what's the output, but you can see something is there, right? So we can't say exact what's feature, but some kind of output you can see, right? Got it? See, right? So different outputs are there. So it extract different features, right? Got it, right? So now, if you apply something like this, can you understand what happens, right? So I'm going to now. Can you explain if you apply this kernel, right? So this kernel, in sense, like we have like 1 divided by 9. We are going to divide like so. We have a kernel with 1 divided by 9, right? So if you apply this kernel, any idea what happens? Yes, if we apply the kernel like this, any idea what will happen? Yes. Yes. Any idea? Yes. Any idea? Not same pixels, right? Not same pixels, but okay, let's assume the kernel values, I mean, not the kernel, the pixel values are x1, x2, x3, and x9, right? So if we apply the neighborhood operation, what happens, right? What happens if you apply the neighborhood operation? It's something like 1 over 9 into x1, right? Plus 1 over 9 into x2, right? Likewise. Then finally 1 over 9 into x9, right? So this can be written as 1 over 9 x1 plus x2 plus x9 up to x9, right? So what is this about? Huh? What? We are averaging the pixel values, right? We are averaging the pixel values, right? So what we are going to get then? A smooth image, right? The average image, or we call a blurred image, right? So we can get a blurred image. Now here we can't see the blurring, right? So since it's like a very small blur, right? So we can't see. But if we apply, I mean, like this, if we apply a 11 by 11 kernel, now here we are applying a 11 by 11 kernel, like np.1s means 11 by 11. So we are going to get like 11 by 11 kernel with 1, right? Then we are dividing it by 1 to 1. Why? 11 into 11 is 1 to 1, right? Got it? Now, why we divide by 9 earlier? 3 by 3 is 9, right? That's why we divide by 9. Now, we are applying a 11 by 11 kernel, right? So if you can't understand what I'm trying to say, print it and see, right? So this is the 11 by 11 kernel, right? So it's a bit larger kernel, right? So now what will happen if we apply it to this image? You can see now it's blurred, right? Blurred. Or we average the pixel. Now the middle pixel is divided by the average of the surrounding pixels, right? Now, first of all, can you understand why this is called neighborhood operation? Huh? Neighborhood operation, can you understand why this is called neighborhood operation? Yes. Why? The center pixel value is determined by the values of the surrounding pixels. That's why it's called neighborhood operation. The center pixel value is determined by the neighbor pixels. Right? Got it? Understood? Now here we can say a bit blurred image, right? Why we are putting like 1 divided by 1 to 1, right? So it's average, right? Got it? So this smoothing, so this is something additional. This smoothing can be used for like noise removal, right? So the pepper noise in the sense, not the all the noise, but the pepper noise. Now in images there are noises, right? Many types of noises. Like the first one is a fundamental noise, whole pepper noise. Like what mean by whole pepper noise? Like black and white dots, right? So pepper noise, for pepper noise we can use this blurring, right? So we can do it using this kernel operation as well. I mean, we can do the blurring using this as well, right? I mean, by taking this kind of 1 by 1, I mean 11 by 11 or 3 by 3 or 9 by 9 kernel, and we can divide it by whatever the value, and then we can do the smoothing, or else we can get it done using this command as well, cv2.blur, right? So this is same as applying this, right? So then you can see if you apply this kind of a kernel, like the image will be somewhat smooth, right? Blurred, but you can see the pepper noise is gone, right? So the pepper noise can be reduced using this one, right? Why? The values get average, right? Got it? Value get average in the sense, now if you have a black color pixel, right? So that black color pixel is now will get averaged from the surrounding pixel. So the black color will be removed. Sorry, this is not this is not good for pepper noise. This is good for salt noise. The white color will be removed, right? So that's something additional, right? So that blurring can be used for noise removal as well, right? Okay, so now we are going to move on to the application of kernels, right? Now, before going on to that, I want to say that don't think that the kernels or this convolutional operation or the neighborhood operation is can be done with 3 by 3 matrices. Not only 3 by 3, you can use 5 by 5, 7 by 7, 8 by 11 by 11, but we are using like always odd number. Why? 3 by 3, 5 by 5, 7 by 7. We always use a odd number. Why? Otherwise, there won't be a center pixel. Right? Otherwise, there won't be a center pixel. That's why we are using a, this kind of what you call this odd number, odd size pixel, right? Okay, right, got it. So now you may be wondering what are the other types of kernels available. There are many kernels available, right? So you can read about them. Now here I have mentioned some kernels as well, right? There are sharpened kernels, Sobel kernels, edge detection kernels, right? So likewise, we have many options, so you can try them out and see the output. So you can come up with your own kernels as well, right? So you can come up with your own kernels as well. But this is simply like I explained you a few kernels, but there are many hundreds of kernels available. I'm not going to explain all of them, right? But you want to know that there are many kernels and they can be used for feature extraction, right? Got it? Okay, so hope you got the idea. right? So any questions from this part? Otherwise, we can move on to the we can move on to our project from this kernel operations, neighborhood operations. Right now, there are many other kernels, like please refer like Sobel kernels, Laplacian kernels, right? And blurring kernels, right? And also like corner detection kernels. There are many kernels, so you can refer them, but I just explained you the application and the minus one that I forgot to mention. Sorry, that's something I forgot. I will ask those. I will answer those questions now. What this minus one does, right? Actually, I also can't remember what this minus one does, but then we can see what actually it does. Let's search it in the internet. So okay, so that is I think depth of the output image. Can we put plus one? You know. Can you put zero? Or you can put zero, right? So you can put minus one and zero, right? It's not clearly explained. Let's see. Actually, I also can't remember, but here it says when you use this depth as minus one, result in the image has the same depth as a source image. That means now we even we can apply color images. Now I will take directly this color image and we can apply the color images as well directly. Right? We can directly apply the color image. Now here I'm directly loading the image, the color image here you can see, right? Directly the color image. So that image can be directly applied here, right? So then you are going to get a color image. Now in the colors are not that much visible, but you can see that The dimensions are like 960, 123, right? So we are going to get a color image. So in order to get the same depth, I mean, when you apply color image, so if you want to get a color output, I mean, the convolution should be also in the color image, then you have to put -1. That's what it says, right? Right? Value -1 represent that the image result has the same depth. That means if you are going to input a color image into the kernel operation, the output will also be color, right? So that's what it says. Okay, right? Right. Then the other thing, the other question that you asked, how does boundary pixel get run? That's a good example I forgot to mention. Now here we have a problem, right? So you can see that, right? So when we apply this kernel operation, right? So when we apply this kernel operation, you can clearly see that what? You can clearly see that when you go through this like this, right? You can see that always, right? See, sorry. See, so what you should see here, that you have to you should note that this boundary, I mean this row, first row and the last row, and the first column and the last column, right? First column and the last column. Right? Got it? The first row, last row, and the first column and the last column. So they are like, we can't calculate a value for them, right? So we can't calculate a value there for them. Why? This is like, this is assigning the value for the center value. So always the top row, bottom row, left column and right column, they are missed, right? So what to do, nothing to do, right? So that means that will be removed from the image. I mean, they will be there. So there are many solutions that you can use. You can keep it like black, or you can make it white, right? So you can keep it black, or you can make it white, right? That's something that you can do. The other thing is, other solution is padding. The padding in the sense like the white padding, black padding, and also you can like this row, right? This row will be replaced with this row, the next row, right? That means we use the second row to replace the first row, right? And also first column will be replaced with the second column. Likewise, that also another method that we can do, right? Follow, right? So those are the options that you have. Either you can either use black or white and fill them. Now here, this is example filling in black, right? So this is totally filled in black, the four boundaries. Or else you can fill it in using white, or you can fill it using the nearest column or row, right? Got it? Okay, good. Hope you understood, right? So now then we are going to move to right. All right, so now I think now don't get confused here, right? So we can apply, right, any size of a kernel, right? I mean, this is example, right? But we can apply any size of a kernel. Now here I am applying like let's say some sample, as I'm just right. Now this is a 5 by 5, right? See, now you are going to see some output, right? So this is applying a 5 by 5. Now I want to show you something. When you apply 5 by 5, like 2 rows, here like 2 rows and 2 columns right? We have neglect 2 rows and 2 columns, right? But if we apply 5 by 5, what will happen? See, oh, I will explain it from here, right? So if you have apply a 5 by 5 kernel, what happens? 5 by 5 kernel, like this. So center value will be somewhere here. Center value will be somewhere here. So then that means like this, right? So you are going to miss 2 rows and 2 columns from each side. That means 4 rows and 4 columns. Understood, right? So bigger the kernel size, the higher the, the rows and columns that you are going to miss in the image, right? Hope you got the idea, right? Okay, so then we are going to move to our next project, right? So in this project, this is our final output that we are looking for, right? This is what we are looking for to implement something like this, right? So this is basically like lane detection, and you can see like we can measure the distance from the vehicle, right? We can measure the distance from the vehicle to the line, right? Got it? So that's what we have done here, right? So this is our project today that we are going to focus on, right? Okay, so let's see. Right, so let's use the video first. Now we have a video here, the sample road drive.avi, right? So I'm going to load that video, and then what I'm going to do is I'll use a while loop, and let's try to load it first. Let's see whether the video is working fine. Right, so first we'll see whether the video is working fine or not, so we can load the video and see, right? So a simple code I have written to load the video, right? Hope you can understand, right? Okay, so the video is loading fine, right? So the video is loading fine, so you can see this video is about like a vehicle is driving on the road, right? So our objective, our simple objective is to detect the lanes and measure the distance from the car to the lane. I mean, if you can detect the lane and if you can measure the distance from the car to the lane, then you can like do something. I mean, if you are interested, you can control the steering based on the distance, right? Correct? I mean, now we have more advanced things like self-driving cars, which uses artificial intelligence nowadays, right? So we can use artificial intelligence and do this, right? But using pure image processing also we can do this now. I mean, these kind of methods are always available, like you have seen in cars, like the lane detection is also already there, right? So here also we are trying to detect the line and do something, right? So if we can detect the line and if we can measure the distance between the line and this, right? So then what will happen? Then we can develop it further to self-drive. How? So based on the distance, we can change the angle, I mean the steering angle, right? Okay, that's only for your like information, right? So now what we are going to do, we are going to use our kernel operations first, right? So before that, We are going to convert it into gray, right? So we are going to convert it into gray first, right? Then let's see the why we need to convert it to, I mean, we have to detect the edges, no, right? So first we will convert it to gray, right? And this is what we are going to see, right? Fine. So then we will use our kernel, right? So we are now, any idea? Do we have to now? We are going to use the edge detection, right? So what about this? Do we need to detect horizontal edges or vertical edges? Huh? Simple question. Yes. Right. It should be vertical edges, right? So I have the vertical, I mean the X filter. So I have the X filter here, right? So you know what X filter we discussed, right? So then what I'm going to do, I'm going to apply that in filter 2D function, right? I'm going to apply the filter 2D function, right? And I'm going to get the convolution. What do you mean by the convolution? Convolution is the, right? Convolution is the, what? Convolution is the output. We refer the output of neighborhood operation, the output image as a convolution, right? So shall we see the convolution? See, right? So this is the output. Now it detects what? So what we did was we did nothing but what? We did simply we apply the filter 2D. Filter 2D function, right? We apply it for what? Vertical edges, right? The X gradient, right? So we have to do more, right? We have to do more. Now we can see like not only the line, yeah, lines are detected. So you can see lines are detected, but there is like the trees are there and other all the other vertical lines are detected, right? Now can you now you saw our final output, the output that we are expected to get, right? So you saw that. Now let me ask you a question, right? So in order to go to that level, what should be the next step? Now let's say that you have detected, now this is what the neighborhood operation about. So we have to apply the neighborhood operation and we got the output like this, right? We got the output like this. Now this is what we have, right? This is what we have now. This is after applying the neighborhood operation, the Sobel X kernel, right? But this is not the end, right? So we have to do more. We have to do lot more in order to go to that output that I just showed like a minute ago, right? So can you all suggest me what should be the next step? Yes. Contour. Okay. Before that, is there anything? Did you miss any other thing? Identify line shape. Okay. Other than that, anything? Just try. I will give one more chance to you all. Is there any other step that you think of? Yes, we should definitely go to the contour operation. Yeah, that's true. But before that, yeah, we have to remove extra lines, right? And one important thing, right? One important thing is that here, this is not a gray. I mean, this is not a gray. I mean, this is not a binary image or a black and white image. This is a gray image, right? It is a gray image. Therefore, the first thing that we should do is we should convert it to a black and white image, right? Therefore, what we need to do is we need to apply thresholding, right? We need to apply thresholding in order to make it a black and white image, right? Otherwise, right, contour detection won't be as successful, right? There will be issues in contour detection, so therefore it's better we can make it black and white, so we know then we have only two colors, right? So that would be easy for contour detection. Now you can see, right, the output. Now this is the gray image, but this is the output that we are now getting after thresholding, right? Okay, now you can see that we have lots of unwanted areas, right? So we have lots of unwanted areas. So what we can do is now the sky and also the bonnet of the car, right? And also this forest, the trees, right? So they are not relevant for our application, right? We are not going to depend on those things in order to detect our lines, right? So therefore that they are not required, right? So what you can do is, now one important thing you can see, right? You can see that I think the output will get better if we blur the image, right? So blurring can remove the unwanted noise. If there is any unwanted noise, so we can remove it. So we can blur the gray image and before applying into the filter 2D. So that's the additional step. So that will make the image clear, right? So that's only for noise removal. So you can apply the blur. So that also always like it's better if you can apply the blurring. So then it will like remove whatever the unnecessary noise are there, right? So you can decide the kernel size of the blur as you want, depend on the image. Right, okay, so that's it. And then, right, what I can do is, right, right, so you can see that the forest thing we can remove, right? So that means if we can make this part, which part? What I'm going to highlight, if you can make this part black, right? So if you can make this part black, what I highlighted in red, if you can make this part black, what will happen, right? Simply, like many unwanted detections will get removed, right? Got it? So what I can do, simply I can do that. How I can do that? I'm going to do something like this. So I'm going to take it here. You can do it for the thresholded image or as well, or convolution as well. I will do it for the thresholded image. That would be easy for us. From the threshold image, what I'm going to do is from 0 to 120, I'm going to make it black. See what this code does? Which code? Here, from like the height, right? From the height side, I'm going to make 0 to 120. I'm going to make it black, right? So that will make our life easy, right? Also, you can even remove the bonnet as well, right? So if you make like, you can make this part also 0, then the bonnet will be also get removed. But that's not necessary since the bonnet is hardly seen here, right? The bonnet is hardly seen, right? So the next step, as you suggested, so I got rid of this unwanted lines and all, right? The next step, as you suggested, we can go for contour operation, right? So we can apply contours, and what we can do is get the contours detected, and also we can draw the contours, right? So I have to decide the contour area, right? I have to decide a contour area in order to get rid of those tiny little dots, right? Now you can see, like, if I draw all the contours, right? I mean, before doing this, I can get rid of all the, I mean, let's see the contours first. We will draw them in red color, right? So let's check the contours first, right? So you can see that there are many contours, right? So we don't need all of these contours, right? So what we can do then, so I just draw all the contours, right? So what we can do then, I can simply get rid of the unwanted contours, right? So I'm going to use a contour area like 200. Then I'm going to consider the contours which has a area less greater than 200, right? So now I think, right, so now I think almost fine, but some unwanted lines are also detected, right? Some unwanted lines are also detected, but that's fine, right? Got it? Right? So everything seems fine now, almost fine. Now what we'll do, we'll try to draw a rectangle, the bounding rectangle, right? So let's try to draw the bounding rectangle first. Give me a second. What I was discussing, right? Yeah, so we'll try to draw a rectangle, right? So we'll try to draw a rectangle, right? Now, when you draw a rectangle, you know these codes, right? So the rectangle, we have already drawn it earlier, right? So you know that there is a issue with this rectangle. What? Huh? We are not getting the rectangle as we expected, right? So what we are expecting the rotate. I mean, we are expecting, we are looking for a rotating rectangle, right? So we are looking for a rotating rectangle, but here this is a straight rectangle. So I explained you this earlier as well. Now what contours, I mean the contour operations we have, right? So this is the bounding rectangle, right? So the bounding rectangle is not rotating, right? So therefore the size, like it's try to draw a rectangle bounding the, and it's trying to actually create a straight rectangle, right? So that's the issue. So therefore we can't go with this one, right? So instead of that, we have something called the bounding rectangle, I mean the rotated rectangle, right? So how we are going to find that one, that's also there in the material that I given to you last day, the links that I provided you last yesterday, right? Right. So if you go to this contour operations, right? So this is how we are going to draw a rotated rectangle, right? So we can use this same code and draw a rotated rectangle. So I have the same code here, right? I'm going to get this code, and this is how we are going to draw the rotated rectangle, right? So it's nothing but this code, right? Okay, so I'm also going to use that here, right? Okay, so then you will see the rotated rectangle, right? So you can see now it's not that kind of a straight rectangle. This rectangle can rotate, right? So that's nice, right? So that's nice, and we are getting what we want, right? What we are expecting. Okay, now almost all the things are done. Now what we need to do is basically like I will show you the final output, right? So we need to get a line, and we need to like measure the distance, right? So that's what we are looking forward to do. Okay, so what we can do is then we can get the like, I mean, what I want is basically when you have this frame, right? So you have the road, I mean the road in the sense the line, and you have the center line. You have the center line. Then this is the road, I mean, right? So this is the road. Right? This is the road. And the center line is basically the car center line, right? So then we need to like draw a line between these two, right? The center of the car, and we have to get the distance between it, right? So in order to do that, we have to find the, like, I mean, we have now detected the, right? So we have now detected the kind of contour, right? So this contour, we need to find the centroid of this contour, right? The centroid of this contour and this line, right? So this is nothing but, now you know that the camera is there in the vehicle, right? Camera is there in the vehicle. So we can get the frame center, right? The center of the frame, and the center of the frame can be considered as the center of the car, right? Why? The camera is there in the car. Got it? Got it? So then what we can do is we can get the, right? We can get the height of the, right? We can get the height of the height and width of the, right? So we can get the height and the width of the camera, I mean the frame, right? So height h and w of like we can get it using the image.shape. So this is something that we have discussed in our first day, right? So we can get the height and the width, right? The first two parameters of the shape. The third parameter will be 3, right? So we have the height, width, and 3. You know these things, right? When you call image.shape, it gives us height, width, and 3 for a color image. So we don't need 3, we need the height and the width, right? So what we can do is I can define a variable like, okay, center center x, or we can like, yeah, center x. Center x is nothing but the width divided by, right? Width divided by 2, right? So why I use double division, right? So double division gives us the integer division, right? So if you divide it by 1, I mean divide it by 2, then this will give like to the float division. But we don't need the float since we are going to have a pixel number, a row number or column number. So therefore we need to get the integer division. So that's why I put 2 slashes. So this gives the integer division. Now what I can do, I can get the image, right? And I can draw this line, right? So image, all rows, this center x column, right? So you can use a particular color like green or whatever the color you are interested. Right? So you go with green, right? So then let's see. Yeah, so you can see a nice line. Sorry, this is not one line. Yeah, I think this one. Yes, you are. Why you are getting a yellow color line? Why is that? Oh, yeah, I put yellow. That's why. Okay, anyway. So a green color line, right? Now that line is okay. Now we need to like, I mean, we need to find the center here, right? Center in the sense, center of this one, right? So if we have the center of that, then we can get this line. Got it? So in order to find the center, you can refer the same document. So in that document, there is the method of finding the center x and center y, the centroid of a contour, right? So finding the center of a contour, right? That means you can find the center of the contour. Center of the contour is like the cx, right? And the cy, right? So you can use this code in order to find that, right? So I also have the same code here, right? I also have the same code where, right? So I'll put that code here, right? So we are going to find the momentum first and then the center x and center y. So then we are going to create a circle from that center x and center y, and this is the radius of the circle that we are going to draw, and this is the color of the circle. It is a green color circle, and this is like for the thickness of the circle, right? So if you put 1, the circle will be like, can you see? It's clearly not seen, so I will increase the size a bit, like 3. So the circle thickness will be 3 here, right? So if you want like get a filled circle, you can put -1. So -1 gives you a filled circle, right? Now it gives a filled circle. So this is the radius of the circle, right? So you can change the radius and you can like change the thickness of the circle. And if you put -1, it will be a filled circle, right? Now you can see that we have multiple, like, I mean, like the other line, I mean, the right side, the center line and the left side line is also detected, right? So the center line is also detected, this dash line, right? And also what we actually need is the left side line, right? So we need to find the method of neglecting the what? We have to find the method of neglecting the. Now, can you understand what I'm trying to say? Okay. So now here 2 contours are detected basically. The left side contour, that's what we need, and the center contour and the right side lane, right? So the right side line and the center line and also left side line are detected. So what we need is we need only the left side line, right? So can you suggest me a method to get rid of the other lines and only get the, I mean, get rid of other contours and get the contour of the left side line? Any suggestion from you? Yes. How to get rid of all the other lines and get the contour for the left side line? Any idea? Right. Okay. So what I'm trying to say, right? Okay. So shall we first draw the line? I mean the line in the sense, right? So what I want is I want to draw a line between these like this. Draw line like this, right? Between that contour center and this line, I want to draw a line like this, right? So how we are going to do that? Quite simple. How? There's a function called cv.line. cv.line. So I'm going to draw a line, right? So we did this yesterday. No, we didn't. So in order to draw a line, we didn't draw the line. So in order to draw a line in OpenCV, what you need to know, right? So you need to provide, in order to draw a line, right? So you need to provide this x1 and y1 and x2 versus y2, x2 and y2, right? 2 edge points of the line, right? So first one will be the center point of the contour that's given by cx, cy. Then the next point, any idea? Right. So this is like, let's say the contour and this is the line. So any idea? Let's say this is the center line and this is cx, I mean centx, right? So we have the centx already, right? Centx already there. And y, I'm going to select the same y as this. Same y of this one, right? So then what we can do is we can then give the color and the thickness, right? So shall we see the output now, right? So that's what I told you, right? So can you see now lines are drawn for all the contours detected, right? So can you suggest me a method in order to get rid of the other contours and only consider the left side contour? Any idea? Yeah, very simple thing you have to do, right? So we have to, we know that center, I mean this center coordinate we know, right? So we are going to always consider the contours which has a center less than the center x, I mean this center. So I'm always going to consider all the contours before this center x value, right? Got it? So quite simple. So what we can do is, I'm not going to do it for all, but I'm going to consider if, okay, this centroid, the contour center is less than the center x, then only I'm going to draw it. Otherwise, I'm not going to draw. So all the other contours right side the center line will be neglected. See, so very easy solution, right? Got it? So now you can get the distance, right? So distance is between this cx and c, right? Got it? So distance is nothing but the difference between the center line, right? Difference between the center line and right, the center x and the center line. So that's what you call the distance, right? So you can put text, using the put text, you can even, so I use put text somewhere. I will get it. I'm going to get it from the earlier code. And I'm going to put it here. And I'm going to use like a random value, like I will increase the font scale a bit. That would be okay. right? That is a bit larger. So let me use a smaller value for the font scale, right? So this is now again gives in millimeters, but you can do the conversion and get it converted to, sorry, this is giving in, this gives you the distance in pixels, but you can do a conversion and get it converted to millimeters, right? Okay, so understood. So quite simple one, and you have all the code with you. So go through each line of the code and try to understand each and every line of the code and try to do it yourself again, right? Okay, so any questions from this? Now later you can use it for like self-driving. I'm not going to do that part, only this part, so you can get the distance between the line and the center. So you can use it for any application like self-driving or whatever, right? So that's the extension. That's something you have to figure out, right? Okay, so any questions from the project? Anything you need to clarify? Okay, so we have a question. Let's see. If we maximize the window, distance will change. Maximize the window. No, not max. No, it's not going to change since like it has a fixed frame size, right? No, it's not going to change. But if you like resize the, I mean, if you change the resolution of the image, yes, then it will be changed, right? So now this is giving in pixels. So like we have to do something like I mentioned you what, like you can measure the real distance and get the ratio and multiply the coming value, then you can get the exact value from what millimeters or centimeters. Similar, you can follow a similar thing that we did for the plant height detection. So you can use the same method and convert it back to like millimeters or centimeters. Right? I mean, sometimes it's not detected, right? So this is not a perfect example, but we can improve it and we can do modifications and get it improved, right? Okay, seems no other questions are there. So let's end the session for today, conclude the session for today. And we are going to meet again on Monday, right? So Monday, 7 p.m. And the topic will be video processing and object detection using Cascade classifier. So we have 2 more days to go. I have provided the recorded video to the coordinator. He told that he will provide it today. So I will ask him again. So anyway, you will get the recorded video. Probably today itself, I will ask you to provide them to you. And you have the weekend and you can go through the videos again. So I will ask him to provide you the videos. So then you can go through them in your free time in the weekend, right? So go through them and get ready and come on next month, right? So I will definitely ask him to provide it today. Okay, so good night, everyone. We will meet again on Monday.